Assalamu alaikum wa rahmatullahi wa barakatuh. Our lecture today about iron homeostasis and effect of hepcidin on iron metabolism. Let us first start by asking the question, what are the chemical forms of iron? Iron can be present inside our body in two forms. Either the ferric form, the oxidized form, it is insoluble at physiological pH, or in the ferrous form, which is the reduced form, and it is soluble and absorbable. And the ferrous form is the form of which the iron is absorbed from the intestine. Iron is highly toxic because it can generate free radicals which can destroy tissue organelles. So iron is kept bound to different proteins like transferrin, ferritin, etc. So it is not present in the free form. The total amount of our body iron in the range of 4 grams in men and about 3 grams in women. The women is somewhat less than men because of their menstruation, maybe the muscle mass, pregnancy, and lactation. Hemoglobin contains most of our body iron, as it contains about 2.4 grams of iron. Iron, as we said, cannot be present in free form because it is highly toxic, generating free radicals. So it is present bound to proteins, either in the form of heme, as in hemoglobin, myoglobin, cytochromes, present inside the electron transport chain, or it may be present bound to protein as iron, not in the form of heme, as in ferritin, lactoferrin, transferrin. Ferritin is the storage form of iron inside the cells. Transferrin is a protein which carries iron in plasma. So iron cannot be present in free form. It has to be present either with proteins, and it may be present in the heme form or as such as iron. If we start talking about iron absorption, we will notice that very little amount of iron is absorbed per day from the upper part of the small intestine, mainly the duodenum. The amount absorbed per day is in the range of 1 or 2 milligrams absorbed per day from this site. Iron is highly regulated at the site of absorption because there is no efficient way of iron secretion or excretion. So regulation of iron level inside our body is through the amount absorbed from the small intestine. If the amount of iron absorbed from the small intestine becomes high, this may raise the level of our body iron, and iron will deposit in various tissues, creating hemochromatosis, which is when iron becomes in excess. Iron is absorbed from the enterocytes by the help of a transporter. Such transporter is termed divalent metal ion. The divalent metal transporter 1, it carries ferrous iron. When iron present in the food is in the form of ferric form, it has to be reduced first by means of HCl of the stomach or by the help of vitamin C to be transformed into ferrous form. Then the DMT can carry iron in the ferrous form to the inside of the enterocyte. To the contrary of that, heme can be absorbed as such, and by the enzyme heme iron will be released into the labile iron pool inside the enterocytes. The iron inside the enterocytes either be stored in the form of ferritin, or it is used for the synthesis of different heme containing proteins, as we mentioned, the electron transport chain cytochromes. Another amount of iron will be absorbed from the enterocytes into the plasma through a transporter protein termed ferroportin. Such ferroportin is present on the basolateral side of the enterocytes, where iron is absorbed and transformed into the ferric form by means of ceruloplasmin or hemopixin, where it is oxidized and carried in the ferric form with transferrin. So iron is absorbed when it is in the free form through the divalent metal transporter, and it is absorbed as such. Maybe a carrier protein here, but is not identified yet. And when it is released or absorbed from the enterocytes, it will be carried in the blood, carried on transferrin after it is transformed from the ferrous form to the ferric form. As I mentioned, that there is no efficient excretory pathway for iron. So iron homeostasis is regulated at the site of absorption from the enterocytes. But small quantities in the range of 1 to 2 milligrams, which are absorbed from the intestine, are lost in the form of desquamation of the intestinal cells and skin, and maybe in the females also in the form of menstrual blood. What's transferrin? Transferrin is the form of which iron is circulating in our blood. So it is a iron carrier protein. It binds iron and transported from the blood to the various tissues. Transferrin carries iron in the ferric form. Each transferrin molecule carries 2 iron molecules in the form of ferric form. Transferrin then circulates in the blood, where by the help of transferrin receptors it will bind to the cells that carry such receptors and be internalized to the various cells where iron can be utilized. Another molecule termed ferritin, and the ferritin is an intracellular iron storage protein. Ferritin keeps iron in soluble and non-toxic form inside the cells. Ferritin is formed from apoferritin when iron combines with it. Serum ferritin levels correlate with the total body iron stores. Thus, serum ferritin is increased in case of iron overload and decreased in case of iron deficiency. Low serum ferritin indicates iron deficiency anemia, maybe in case of hypothyroidism or vitamin C deficiency, while high levels of serum ferritin may be due to acute and chronic inflammations, or as in cases of hemochromatosis that will be discussed later on. When ferritin level inside the tissue cells are getting higher and higher, excess iron will be deposited, bound to the proteins inside the cell, and becomes insoluble and precipitated in the form of hemosiderin. So we can summarize iron absorption in this diagram, where iron, when it is absorbed or released into the plasma, it will be bound to transferrin, where by the help of transferrin receptors, it will be internalized to the different tissue cells, where iron uptake to the inside of the cells. Iron inside the different cells will be used for the synthesis of different hemoproteins mentioned before, and the excess iron will be stored inside the cells in the form of ferritin. So what are the sources of plasma iron? Plasma iron can be absorbed through the enterocytes, mainly the duodenum and the upper part of small intestine, as we mentioned before, or may be released from the macrophages and hepatocytes. Iron, when it is absorbed from the enterocyte or released from the macrophages or hepatocytes, the iron transporter, the only iron transporter identified in humans, is a protein termed ferroportin. Ferroportin is the protein through which iron is transported or released, absorbed from the enterocyte or released from macrophages or hepatocytes to the blood or to the plasma, where iron is oxidized and transported, carried on transferrin. Let us now ask the question, what is hepcidin? Hepcidin is an iron regulatory peptide. It is synthesized in the liver. So hep is liver. Cidin means antimicrobial polypeptide. It is a small polypeptide hormone, about 25 amino acids in length, and it is the main regulator of iron homeostasis through controlling ferroportin. So hepcidin controls iron absorption or iron released from the macrophages or hepatocytes by controlling or by acting on ferroportin. Ferroportin, on the other hand, is a membrane-bound receptor which is controlled by hepcidin. It is a transmembrane, about from 10 to 12 segments running in the cell membrane, and it is present in macrophages, duodenum, hepatocytes, and the placenta. When hepcidin binds with ferroportin, it causes its internalization. Internalization means that no iron will be absorbed or released into the general circulation, and the iron will present inside these cells in the form of ferritin. So hepcidin will lower serum or plasma iron because it binds with the channel for iron transport, causes its internalization and its inability to release or absorb iron to the blood. So if hepcidin levels are high, we will get low levels of ferroportin. That's to mean retention of iron within the cells and cytoplasmic ferritin, and that will decrease the amount of iron absorbed or iron released into the plasma. On the other hand, if hepcidin levels are low, that would mean that ferroportin is abundant and released from the inhibitory effect of hepcidin, so iron will be absorbed in large quantities from the intestine or released from hepatocytes and macrophages, and that would increase the plasma iron. This diagram shows that ferroportin is nothing but an iron transporter from enterocytes, macrophages, and liver. When hepcidin binds ferroportin, it causes its internalization and its degradation. That would decrease iron absorption and release, and consequently the decrease of plasma iron level. On the other hand, if there is a decreased level of hepcidin, or the process of binding of hepcidin with ferroportin is mutated, in other words, that the hepcidin cannot bind with ferroportin, that will lead to no binding together, and in other words, there will be no degradation of ferroportin and increased iron absorption from the intestine and release from the liver and macrophages, causing increased plasma levels of iron. This form shows how hepcidin works. Hepcidin shuts the iron absorption from the duodenum or the intestine, and iron release from the macrophages and liver. The mechanism of iron homeostasis is very important, as we are going to see later on in hemochromatosis. In hemochromatosis, the process of regulation of iron absorption is defective, and that would lead to increased levels of iron absorbed, with consequent rise of iron deposition in various body tissues. Let us talk about the abnormalities of iron level. Iron levels may be decreased, as in iron deficiency, and that would cause cellular dysfunction and anemia, or it may becomes high, as in iron overload. When iron overload exceeds the binding capacity of transferrin, the iron overload that causes tissue and organ damage. In iron deficiency anemia is the most common type of anemia. What we are going to find, the laboratory findings in iron deficiency anemia, it is hypochromic microcytic anemia, and serum ferritin levels in plasma is decreased, and transferrin saturation decreases. It is less than 35%, it may be 15% or less. Iron deficiency is more common in women than in men due to menstruation, pregnancy, and birth. Iron deficiency anemia is seen in a patient, in male patient. The patient should always be checked for blood loss from gastrointestinal tract. Another type of anemia is the anemia of chronic disease. In such condition, hepcidin level is increased, and as a result, the ferroportin level is decreased. There will be decreased transport of iron from tissues to the blood, and that would result in mild anemia combined with increased iron stores. So there will be low transferrin saturation, but with high serum ferritin. Thank you.